You want to over-optimize, and every engineer, including especially myself, loves to over-optimize. And when you first have an idea of how to build the agent, you're going to sit down and say, oh, and then I'm going to prevent this hallucination by doing this prompt, and then this prompt, and then this prompt. Don't do that. Just a simple loop, and get out of the way, and just delete scaffolding, and less scaffolding, more model is kind of the tagline here. And this is the leaderboard from this week. Obviously, these models are getting better and better. We could have a whole conversation, and I'm sure there's been many conversations about, is it slowing down, is it plateauing? It doesn't really matter for this talk. We know it's getting better, and they're getting better at tool calling, and they're getting better optimized for running autonomously. And I think Anthropic calls this like the AGI pill way to think about it, is don't try to over-engineer around model flaws today, because a lot of the things will just get better and you'll be wasting your time. So here's the philosophy, the way I see it, of Claude Code. Ignoring embeddings, ignoring classifiers, ignoring pattern matching. We had this whole RAG thing. Actually, Cursor's bringing back a little bit of RAG and how they're doing it, and they're mixing and matching. But I think the genius was Claude Code is that they scratched all this, and they said, we don't need all these fancy paradigms to get around how the model's bad. Let's just make a better model and then let it cook. And just leaning on these tool calls and simplifying the tool calls, which is a very important part. Instead of having a workflow where the master prompt can break into 3 different branches and then go into 4 different branches, there's really just a few simple tool calls, including grep instead of RAG. And and that's kind of what it's trained on. So these are very optimized tool calling models. So this is the Zen of Python, if you guys are familiar. If you do import this in Python, I love this philosophy when it comes to building systems, and I think it's really apt for how Claude Code was built. So really just simple is better than complex, complex is better than complicated, flat is better than nested. This is all you need to, this is the whole talk. This is all you need to know about how Claude Code works and why it works specifically. That just, we're going back to engineering principles such that simple design is better design. I think this is true whether you're building a database schema, but this is also true when you're building these autonomous coding agents. So I'm going to now kind of break down all the specific parts of this coding agent and why I think they're interesting. So the first is the constitution. Now, a lot of this stuff we kind of take for granted, even though they started doing it a month or 2 ago, or maybe 3 or 4 months ago. So this is the Claude MD. Codex or others use agents MD. The interesting thing, I assume most of you know what it is. It's where you put the instructions for your library. But the interesting thing about this is it's basically the team saying, we don't need to over-engineer a system where the model first researches the repo. And Cursor, like Cursor 1.0, as you know, makes VectorDB locally to understand the repo and kind of does all this research. They're just saying, just put a markdown file, let the user change stuff when they need, let the agent change stuff when they need. Very simple. And kind of goes back to prompt engineering, which I'm a little biased towards because Prompt Layer is a prompt engineering platform. But everything's prompt engineering at the end of the day, or context engineering. Everything is how do you adapt these general purpose models for your usage? And the simplest answer is the best one here, I think. So this is the core of the system. It's just a simple master loop. And this is actually kind of revolutionary considering how we used to build agents. Everything in Claude Code, and all the coding agents today, Codex and the new Cursor and AMP and all of that, it's just one while loop with tool calls, just running the master while loop, calling the tools, and going back to the master while loop. This is basically 4 lines of what it's called. I think they call it N0 internally, at least based on my research. But while there are tool calls, run the tool, give the tool results to the model, and do it again until there's no tool calls, and then ask the user what to do. The first time I did this, the first time I used tool calls, it was very shocking to me that the models are so good at just knowing when to keep calling the tool and knowing when to fix their mistake. And I think that's one of the most interesting thing about LLMs. Just they're really good at fixing mistakes and being flexible. And the more, just going back, the more you lean on the model to explore and figure it out, the better and more robust your system is going to be when it comes to better models. So these are the core tools we have in Claude Code today. And to be honest, these change every day. You know, they're doing new releases every few days, but these are the core ones that I found most interesting to talk about. There could be 15 tomorrow. There could be down to 5 tomorrow. But this is what I find interesting. So first of all, read. Yeah, they could just do a cat. But what's interesting is read is we have token limits. So if you've used Claude Code a lot, you've seen that sometimes it'll say, this file's too big or something like that. That's why it's worth building this read tool. Grep, glob. This one's very interesting, too, because it goes against a lot of the wisdom at the time of using RAG and using vectors. And I'm not saying RAG has no place, by the way, either. But in these general purpose agents, grep is good. And grep is how users would do it. And I think that's actually a high-level point here. As I'm talking about these tools, remember, these are all human tasks. We're not making up a brand new tool for the model to use. We're kind of just mimicking the human actions and what you and I would do if we were at a terminal trying to fix a problem. Edit makes sense. I think the interesting thing to note in edit is it's using diffs, and it's not rewriting files most of the time. Way faster, way less context used, but also way less issues. If I asked you to, if I gave you these slides and asked you to review the slides, and you read it and had to write down all the slides for me in your new revisions, versus if you could just cross out things in the paper, the crossing out is way easier. Diff is kind of a natural thing to prevent mistakes. Bash is the core thing here, I think. You could probably get rid of all these tools and only have bash. And the first time I saw this, when you run something in Claude Code and Claude Code creates a Python file and then runs the Python file, then deletes the Python file, that's the beauty of why this thing works. So bash is the most important, I'd say. Web search, web fetch. The interesting thing about these is they move it to a cheaper and faster model. So for example, if you're building some sort of agent maybe on your platform and you're building an agent and it needs to connect to some endpoints, some list of endpoints, it might be worth to bring that into a kind of sub-tier as opposed to that master while loop. That's why this is its own tool. To-dos, we've all seen to-dos. I'll talk about it a little bit more later, but keeping the model on track, steerability, and then tasks. Tasks is very interesting. It's context management. It's how do we run this long process, read this whole file without cluttering the context? Because the biggest enemy here is when your context is full, the model gets stupid, for lack of better words. So basically, bash is all you need. I think this is the one thing I want to drill down. The amazing thing there's two amazing things about bash for coding agents. The first is that it's simple, and it does everything. It's very robust. But the second thing that's equally important is there's so much training data on it because that's what we use. It's the reason that models are not as good at Rust or less common programming languages, just because there's less people doing it. So it's really the universal adapter. You have thousands of tools. You could do anything. This is that Python example I gave. I always find it so cool when it does the Python script thing or creates tests, and I always have to tell it not to. But all these shell tools are in it, and this is, I find myself using Claude Code to spin up local environments where normally I'd have like 5 commands written down on some file somewhere, and then they get out of date. It's really good at figuring this stuff out and running the stuff you'd want to do. And it specifically lets the model try things. So Yeah, the other suggestions here and the tool usage, I think there's a little bit of a system prompt that tells it which to use and when to use which tool over which. And this changes a lot, but these are kind of like the edge cases and the corners you find the model getting stuck in. So reading before editing, they actually make you do that using grep, the tool, instead of the bash. So if you look at the tool list here, there's a special grep tool. There could be a lot of reasons for that. I think security is a big one, and sandboxing, but then also just that token limit thing. Running independent operations in parallel, so kind of pushing the model to do that more. And then also like these trivial things like quoting paths with spaces. It's just the common things. I'm sure they're just dogfooding a lot at Anthropic, and they find it, and they're like, all right, we'll throw it in the system prompt. OK, so let's talk about to-do lists. Now, again, a very common thing, but was not a common thing before. So this is actually, I think, a to-do list from some of my research for this slide deck. But the really interesting thing about to-do lists is that they're structured, but not structurally enforced. So here are the rules, one task at a time, mark them completed. This is kind of stuff you would expect. Keep working on the in progress if there's blocks or errors, and kind of break up the tasks into different instructions. But the most interesting thing to me is it's not enforced deterministically. It's purely prompt-based. It's purely in the system prompt. It's purely because our models are just good at instruction following now. And this would not have worked a year ago. This would not have worked 2 years ago. There's tool descriptions at the top of the system prompt. We're kind of injecting the to-dos into the system prompt. They're not, but it's not enforced in actual code. And again, maybe there's other agents that take an opposite path. I just found this pretty interesting, that this, at least as a user, makes a big difference. And it doesn't even see, it seems like it was very simple to implement, almost a weekend project someone did and it seemed to work. Could be wrong about that as well, but so yeah, it's literally a function call. It's the first time you ask something, the reasoning exports this to-do block, and I'll show you what the structure is on the next slide. There's IDs, there's some kind of structured schema and determinism, but it's just injected there. So here's an example of what it could look like. You get a version, you get your ID, a title of the to-do, and then it could actually inject evidence. So this is seemingly arbitrary blobs of data it could use. And the IDs are hashes that it could then refer to. Title, something human readable. But this is just another way to structure the data. And in the same way that you're going to organize your desk when you work, this is how we're trying to organize the model. So I think these are kind of the 4 benefits we're getting. We're forcing it to plan. We get to resume after crashes, Claude Code fails. I think UX is a big part of this. As a user, you know how it's going. It's not just running off in a loop for 40 minutes without any signal to you. So UX is non-negligible, even though UX might not make it a better coding agent. It might make it better for us all to use. And the steerability one. So here's 2 other parts that were under the hood. Async buffer, so they called it H2A. It's kind of the I/O process and how to decouple it from reasoning, and how to manage context in a way that you're not just stuffing everything you're seeing in the terminal and everything back into the model, which again, context is our biggest enemy here. It's going to make the model stupider. So we need to be a little bit smart about that, and how we do compact and how we do summarization. So here you see when it reaches capacity, it kind of drops the middle, summarizes the head and tail. Then we have that's the context compressor there. So what is the limit? 92%, it seems like, something like that. And how does it save long-term storage? That's actually another kind of advantage of Bash, in my opinion, and having a sandbox. I would even make a prediction here that all ChatGPT windows, all Claude windows are going to come with a sandbox in the near future. It's just so much better because you can store that long-term memory. And I do this all the time. I have Claude Code skills for deep research and stuff like that, and I'm always instructing it, save markdown files, because the shorter the context, the quicker it is, and the smarter it is. So this is what I'm most excited about. We don't need DAGs like this. I'll give you a real example. So some users of prompt layer, different agents like customer support agent, basically everybody was building DAGs like this for the last 2.5 years. And it was crazy, hundreds of nodes of, okay, if this user wants a refund, route them to this prompt. If they want this, and a lot of classifying prompts. The advantage of this is you can kind of guarantee there's not going to be hallucinations, or guarantee there's not going to be refunds to people who shouldn't be having refunds, or kind of that prompt. It solves the prompt injection problem, because if you're in a prompt that purely classifies it as X or Y, injecting doesn't really matter, especially if you throw out the context. Now, we kind of bring back that attack vector, but the major benefit is we don't have to deal with this web of engineering madness. And it's 10x easier to develop these things, 10x more maintainable, and it actually works way better because our models are just good now. So this is kind of a takeaway, is rely on the model. When in doubt, don't try to think through every edge case and think through every if statement. Just rely on the model to explore and figure it out. And I was actually 2 days ago, I think, or yesterday, sometime this week, I was doing an experiment on our dashboard to add, trying these browser agents. And I wanted to see if I could add little titles to all our buttons, and it would help the agent navigate our website automatically. And it actually made it worse, surprisingly. And maybe I could run it again, and maybe I did something wrong with this test. But it made the agent navigate prompt layer worse, because it was getting distracted, because I was telling it, you have to click this button, then you have to click this button, and then it didn't know what to do. So it's better to rely on exploration. You have a question?
Yeah, I'll push back a little bit.
Please.
I'll admit any scaffolding we create today to resolve the idiosyncrasies of limitations will that'll be obsolete 3 to 6 months. Even if that's the case, they help a little bit today. How do you balance that wasted engineering to solve a problem we only have for 3 months?
It's a great question. So just to repeat, the question is basically, what is the trade-off between solving the actual problems we have today, and if you're relying on the model that can't do it yet, but it'll be able to do it in 3 months, right? It's case by case. It depends what you're building. If you're building a chatbot for a bank, you probably do want to be a little bit more be careful. To me, the happy middle ground is to use this agent paradigm of a master while loop and tool calls, but make your tool calls very rigorous. So I think it's OK to have a tool call that looks like this, or looks like half of this, in the same way that Claude Code uses read as a tool call, or grep as a tool call. So for the edge cases, throw it in a structured tool that you can then eval and version and stuff like that. And I'm going to talk a little bit more about that later. But throw it in that structured tool. But for everything else, for the exploration phase, leave it to the model, or throw some system prompt. So it's a trade-off, and it's very use case dependent. But I think it's a good question. Thank you. So yeah, just back to Claude Code. We're getting rid of all this stuff. We're saying we don't want ML-based intent detection. We don't want regex. We don't want it uses regex a little bit, but we don't want regex baked into it. We don't want classifiers. And there was a long time, we actually built a product for prompt layer. We never released it because there was only a prototype of using a ML-based, like a non-LLM-based classifier in your prompt pipeline instead of LLMs. And a lot of people have a lot of success with it, but it feels more and more like it's not going to be that helpful unless cost is a huge concern for you. And even then, cost is, the smaller models is going less and less as kind of financial engineering between all these companies pays for our tokens. So Claude does also this smart thing, I think, with the trigger phases. You know, you have think hard, think harder, and ultra think is my favorite. And this lets us use the reasoning budget, the reasoning token budget, as another parameter that the model can adjust. And this is actually, the model can adjust this, but this is how we force it to adjust. And as opposed to, you could make a tool call for hard planning, and actually there's some coding agents that do this, or you can let the user specify it and then just on the fly change it. So this is one of the biggest topics here, sandboxing and permissions. I'm going to be completely honest. It's the most